User Coordinate System. This lesson is mainly about JAKA app. The User Coordinate System setting mainly includes the following contents. 1. The calibration of User Coordinate System. And 2. Application scenarios for User Coordinate System. The course lasts about 15 minutes, and the objectives of the course are 1. Be able to calibrate a user coordinate system independently, and 2. Understand the usage scenario of user coordinate system. What is necessary to calibrate user coordinates? Let's look at the first part of the user coordinate system and see why we need to calibrate the user coordinate system. Firstly, the calibration of user coordinate system can facilitate the teaching of point positions. In some application scenario, the direction of robot would coordinate system is not parallel to the working plane. For example, in a tilted working plane shown on the right, it is difficult to teach the point position of the working plane in a world coordinate system. It is convenient to calibrate a user coordinate system parallel to the working plane. Secondly, by setting different coordinate systems in the program, the offset function of the overall motion track is realized. And finally, move in a relative straight line in a specific direction, calibrate the user coordinate system, and move in a relative motion in a user coordinate system to avoid the problem of non-alignment between the relative direction and the direction of the world coordinate system. Before we get to the user coordinate system, let's take a look at the world coordinate system. The default user coordinate system is the world coordinates, which cannot be modified. The world number analysis originally found that the line direction between the center of the base and the interface of the heavy load line is the positive direction of the x-axis of the world coordinate system. The vertical direction of the base refers to the positive direction of the body in front of the camera is the positive direction of the z-axis. And the positive direction of the y-axis of the world coordinate system is determined according to the right-hand spiral value. At the coordinate system of JAKA are the right-hand coordinate system. Use your right hand to make sure that your thumb points the direction of our x. Your middle finger points in the direction of our z. And your index finger points in the direction of our world y-axis. User coordinate system in addition to the world coordinate system. JAKA opens up to 10 user coordinate systems with editable parameters for the user. As shown in figure, in our app setting, set user coordinate system operation interface. You can set the parameters of the user coordinate system with 6 parameters. The first 3 parameters for the position and the 3 other parameters for the angles. The angles are expressed in Euler angle coordinate system relative to the world coordinate system. If the user coordinate analysis direction is consistent with the world coordinate system, then the attitude is 3 zeros. 2 methods of setting user coordinate system. First one, input settings. Calculate the desired user position as a system relative to the world according to their own needs. Fill this data into the corresponding data box, then click OK. Second method, the 3-point setting automatically calculates the desired position and attitude parameters of the users by setting 3 position points by the user. The definition of these 3 points: point 1 wants the origin of the user coordinate system. Point 2 wants the position of the positive direction of the x-axis of the user coordinate system. And the point 3 wants any point in the first quadrant of the x-y plane of the user coordinate system. Now, let's watch the video. In the setting interface, you can set the user coordinate system by manually entering our data as a series of parameters. For example, if 100 is entered, it indicates that the Z direction of the user coordinate system is shifted upward by 100 millimeters. In the manual view screen, you can see that the user coordinate system has been shifted 100 millimeters upward along the Z direction. Now, the second way, the 3 points setup. Click on the first point to set the coordinate system. The first point is the origin of the coordinate system. Set the second point to be any point along the x-axis. Set the third point. The third point is the x or y plane, any point in the first quadrant. Click OK after setting the 3 points to automatically calculate the user coordinate system parameters. The user coordinate system is selected in the manual operation interface, and the robot can be taught in this coordinate system. User coordinator 3 point for setting nodes. A calibration user coordinate system of 3 points, the attitude of the need to keep consistent. The distance between the 2 or 3 points should be as large as possible so that the user coordinate system will be more accurate. The second part, user coordinate system programming applications. First, set the meaning of user coordinate system instruction. Select the user coordinate system that has been set. Click the user coordinate system drop-down list and select the word coordinate system or the 10 user coordinate systems that have been set. Second, set the user coordinate directly. To create a user coordinate system, click the instruction setting interface. You can manually enter the parameters of the user coordinate system or dragging the array variables. Then Relative linear motion in the user coordinate system. You can choose the reference coordinate system. When the reference system is selected as the user coordinate, the straight line motion will be made in the direction of the user coordinate. User coordinate system application case 1. Set different user coordinate system to achieve the overall migration of the motion trajectory. In the interface of setting user coordinate, set two user coordinates by manual setting, such as user coordinate system 2 and 3 in the right picture. The offset of Z direction is 50 mm and 100 mm respectively. The following is an example. Firstly, we set the user to make the event of moving 5 points in a straight line. Then, change user coordinate and make the same 5 points, and so on for 3 times. Watch the corresponding motion video. We run the program. So first of all, the robot moves in the world coordinates and do the 5 positions we set in advance. The overall point position of the robot moves upward 50 mm and 100 mm in the user coordinate system 3. In this video, we can see that the same program which moves the square has different results after setting the different user coordinates. User coordinate system application case 2. In user coordinate system, the tray movement is realized by relative linear motion instruction. In the setting operation, set user coordinate system interface with a 3-point method to establish the user coordinate system as shown in the right picture. First, set the tray X to count 0. Set the count in the Y direction to 0. Set the distance between the pallet in the X direction to 120 mm and the distance between the pallet in the Y direction to 120 mm. We set the user coordinate just created and set initial position. Let's play the video. Wait for 1 second and set the offset of the array subscript 0 is equal to the program variable x times the program variable delta x. The cluster calculates the distance to the straight line motion x squared. Call down the command. Set the offset of the array element to 1 is equal to y times the distance to the line motion delta y. Make a relative linear motion in advance under the user's matching. Drop 50 mm after the movement is in place, and then rise 50 mm after waiting for 1 second. When the movement is complete, increase the x count by 1, then make a judgment that the x count is equal to 3, reset the x count and increase the y count by 1. If y count is equal to 3, reset y. The program realizes a 3 times 3 pallet instruction by making a relative linear motion under the user's generator. That is the end of this lesson. Thank you for watching.